Hi, thanks for joining me. Today I've got a fun number theory problem for you. We want to prove that there exists an infinite subsequence of the tetrahedral numbers, which is pairwise coprime. So let's break this down a little. Firstly, what is a tetrahedral number? Well, it's simply any number of this form here. So Tn, which is what I'm going to use to denote a tetrahedral number, is a 6 times n plus 1 times n plus 2 for a positive integer n. And then we want to prove that we can find an infinite subsequence of these guys here, such that they are pairwise coprime. So we want to find a subsequence, so an infinite set of tetrahedral numbers, such that when we take any two distinct ones, they're not going to share any common factors. Anyway, if you want to have a go at this problem, pause the video now and give it a go for yourself, and I'm going to jump straight into a solution. Okay, so the way we're going to solve this problem is kind of by induction. What we're going to do is suppose we have the first, say, m terms in our sequence, and then show we can generate the next one along. So we're going to generate, or we're going to have, suppose we have the first m terms, and all of them are tetrahedral numbers, all of which are coprime, and then show we can generate another one. And then kind of by repeating this process by induction, we're going to generate a subsequence of tetrahedral numbers, all of which are pairwise coprime. So let's get stuck into that. Suppose we have m of these numbers already. So suppose we have a1 is less than a2 is less than, and so on is less than am, are pairwise coprime tetrahedral numbers. And then, as I said, we want to generate another one, and I guess one thing we want to ensure is that the next one we generate is not a repetition of one of these ones here. So one way to guarantee that it's not a repetition of one of these ones here is to ensure that it's bigger than all of these guys here. So what we're going to do is define A just to be the product of these guys here. So A1 times A2 times so on all the way up to AM, like so. And then our next triangular number, or again the next one on our list, is going to be T sub 6a plus 1. Okay, so I claim that this guy here will be, it's firstly very clearly a tetrahedral number, but I claim that it's going to be pairwise coprime to these guys here. So it's going to be coprime to each of the AIs, and then it's also, I claim that this guy here is bigger than AM. To see that it's bigger than AM, hopefully it's quite clear, because 6a plus 1, well, 6a plus 1 is bigger than A, and A is bigger than AM, or bigger than or equal to AM by this guy here. So certainly the tetrahedral number, because the Tn is very clearly going to be bigger than n. So this guy here is going to certainly be bigger than am, so it's certainly a new distinct element on our set. So all we have to do now is just check that it's coprime with each of these guys here. And that's actually not too difficult. Let's use our formula up here. So t of 6a plus 1, well, what does that equal to? It's equal to a 6 times n, but n in this case is 6a plus 1. Multiplied by n plus 1, which is just going to be 6a plus 2, and then n plus 2, which is going to be 6a plus 3. But then we can take a factor of 2 out of this guy here, and a factor of 3 out of this guy here, to give us a factor of 6, which is going to cancel nicely with this guy here. So get rid of this, take out a factor of 2 from here to give us 3a plus 1, and take out a factor of 3 from here to give us 2a plus 1, like so. So we got the 6a plus 1 tetrahedral number, is 6a plus 1 times 3a plus 1 times 2a plus 1. But remember, we want to show that this guy here is coprime to each of these things here. But notice, if we just consider both sides mod A, then this guy here is congruent to, well, this thing here is just 1 mod A, this thing here is just 1 mod A, and this thing here is just 1 mod A. So all in all, this is just 1 mod A. So certainly, this number here, T6a plus 1, is coprime to A, but remember A is just the product of all these AIs, so certainly T6a plus 1 must therefore be coprime to each of these AIs here as well. And that solves our problem. We've generated a tetrahedral number which is bigger than all of these guys here, is coprime to all of these guys here, so we can kind of add that onto our list, and then, as I said, by induction we can keep adding one to our list to then generate an infinite sequence of tetrahedral numbers which are pairwise coprime. I hope that has all made sense, and I hope you have enjoyed this video. Thank you for watching. I'll catch you in the next one. Have a great day.